So now we're trying to do some trig application problems, some story problems with angle of elevation and angle of depression. The angle of elevation is simply the angle from the horizontal looking up. So right here would be the angle of elevation. The angle of depression, you have to be careful. It's from the horizontal looking down. So I drew a story problem here. Here's this guy on the top of a building and he sees someone stealing a car down below. Now, the angle of depression is going to be this blue angle. So it's the angle from the horizontal looking down. So this is your angle of depression. A lot of students get confused with this angle here, thinking it's the angle of depression, and it's not. So you always have to draw it from the horizontal down. So let's try a story problem. If you stand 12 feet from a statue, the angle of elevation to the top is 30 degrees and the angle of depression to the bottom is 15 degrees. So what I recommend doing is draw yourself a person. And so here's my person, and they are standing here, and they're 12 feet away from a statue. And then here is my statue, and I don't know what the statue is, but I don't know. There's the statue. And so from the horizontal, here's the horizontal. Let's look at the angle of elevation. The angle of elevation is up to the top, which is 30 degrees. And then the angle of depression is to the bottom of the statue, which is 15 degrees. And again, remember, from her to the statue, here's my statue in red. So there's my statue. Don't ask me what this is. It's the statue's arm. All right. So anyway, to the top is 30 degrees, to the bottom is 15. And then we know the distance here is 12. All right. So the question is, how tall is the statue? So what we're going to do is we're going to figure out maybe from here up and call it X. And then we're going to look at this part and call it Y. And I guess I should say that this is not drawn to scale because this 15-degree angle should be a little bit smaller. But anyway, so looking at this, I have the angle and I don't have the opposite, but I do have the adjacent. The adjacent is 12. So I want to use opposite over adjacent. I don't want to use hypotenuse because I have no idea what the hypotenuse is. So I want to use tangent. So you would say the tangent of 30 degrees is equal to opposite over adjacent. And then multiply the 12. So 12 tangent of 30 degrees equals X. Make sure your calculator is in calculator mode, and then you're going to type that into your calculator. And so this is going to end up giving you, I need to grab my calculator. So you're in degree mode. And then you're going to type in 12 tangent of 30. Close the parenthesis, and you get 6.928. So this height is 6.928. And now we're going to look at this angle of depression. So looking at the angle of depression, it's the tangent of 15 degrees is equal to y over 12. Why did I put x? I have no idea. 12. So take the 12 and multiply it. So 12 tangent of 15 degrees equals y. Throw that into your calculator. So 12 tangent of 15, and your answer is 3.215. 3.215. And so you can see how tall is this statue. We're just going to add these two heights, and the height of the statue is, on your calculator, you can do plus and then arrow up and grab the 6.928. And you're going to get 10.144 feet. 10.144 feet. And that is how tall your statue is. Again, my picture wasn't drawn really great because this height should be almost twice as tall as that height. So, disclaimer, picture not drawn to scale. All right, let's look at the next problem. Two boats lie in a straight line with the base of a cliff at 21 meters. So draw yourself a cliff and we'll label it 21 meters high. The angles of depression are 53 degrees to the nearest boat and 27 degrees to the farthest boat. So here's your water, and I'm going to draw two boats. So here's my nearest boat, and here's my furthest boat. And what we're trying to do is figure out how far apart these two boats are. And we're going to use the angle of depression. So the first thing we'll do is the angle of depression is going to go from the horizontal. So if this is your person on the cliff, from their eye level, so from the horizontal down to the boats. So you can see that the boat that's closer is going to be a larger angle. This is going to be 53 degrees compared to the boat that's way out here. That angle is going to be 27 degrees. All right. So I've got two triangles, and what you can do is bring this up to form a right angle with the horizontal. So you basically have two triangles. You've got this purple triangle and you've got this green triangle. All right. And if we take and find the side of the purple triangle, so we'll call this entire length y, and we subtract the side of the purple triangle, we'll call this x, then we know that y subtract x is going to equal the distance between the two boats. So that's the distance. You're taking the whole, subtract a part, and it's going to give you the other part, which, if you want to highlight, is this part, which is the same as this down here. Okay? All right, so I know the opposite sides. The opposite sides are 21. These are the same height as the cliff. And I know the angle. And I'm looking for the adjacent side. So I'm going to use tangent. So here I go. The tangent, and let's do the purple triangle first, of 27 degrees is equal to opposite over adjacent. And the adjacent side we're going to call y. So now y tangent of 27 degrees is going to equal 21. And then you're going to, y tangent of 27 degrees is equal to 21. And then you would divide by tangent of 27 degrees. So y equals 21 divided by the tangent of 27 degrees. So throw that into your graphing calculator, use a fraction bar, and then in the top type in 21, and on the bottom type in tangent of 27 degrees, enter. And you're going to get 41.215. So y equals 41.215. So that's the full length, and that would be in meters. Okay, so now let's find this purple triangle, or no, the green triangle, and let's find this side. So we're looking for this side right here of the green triangle, which is the adjacent side. So we'll do tangent again, and we'll say the tangent, and this time it's 53 degrees. It's a larger angle because it's closer to you, so you have to look down more, which creates a bigger angle from the horizontal. So the tangent of 53 degrees is equal to O opposite over adjacent. We're going to call that X. All right. So you'd multiply X, so you have X tangent of 53 degrees is equal to 21. So X is equal to 21 divided by the tangent of 53 degrees. You want to make sure that you're in degree mode, and then you can go fraction bar, enter, and then 21, and on the bottom type in tangent of 53 and close the parenthesis. This is going to give us 15.8246. So X equals 15.82. 824 is going to go to 5. All right. So 0.825. Now, really, you want to use the full numbers. So I'm just going to arrow up and grab the full 41 point, subtract, arrow up, grab the full 15, enter, and the distance right here is going to be 25.390 meters, 390 meters. And that's the distance between the two ships. So example 3, a boat leaves San Diego at 30 nautical miles per hour on a course of 200 degrees. And the 200 degrees is going to be a bearing. All right. So let's draw out what this looks like. So here is your bearing, starts north, and it would go 90, 180, and then 200 degrees would be from 180. You would go another 20 degrees. And then here is your boat that's moving out from San Diego. So from where you're leaving from is usually from the origin. All right. So this angle here happened to be 20 degrees because it went 180 and then 20 more for 200. 2 hours later, the boat changes course to 290 degrees. So how you do this is when you're changing course from here, you would go around 90, 180, 270, and then 290. So that's where you change course. And now this boat is going in this direction. All right. Now, the length is the distance traveled. And so if the boat's traveling 30 nautical miles and it goes for 2 hours, that means that it went 60 nautical miles. And then it changed direction and it went another 30 nautical miles because it only went for 1 hour. Now, changing direction, you can see if it's 290 subtract 200, this angle right here where it changed direction happens to be a 90-degree angle is where it changed. All right. And then it says, what is the boat's bearing and the distance from San Diego? So this is the boat coming back to San Diego. That's going to be the hypotenuse, which is the distance. So this is your distance back to San Diego. Your bearing is going to be, you start here and you go 90, 180, and we come all the way to here. And we need to figure out what that angle is for our bearing. Okay, so let's start with our distance. We basically have a right triangle, so we can just use Pythagorean. We really don't have to use trigonometry to figure out the this angle here, or actually this side here. So it's just a squared plus b squared equals c squared. So 30 squared plus 60 squared equals, I'll call it D for distance to San Diego squared. And so throw that into your calculator and you're going to get distance is equal to the square root of 30 squared plus 60 squared. So let me put that in my calculator. Second square root, 30 hit the x squared plus 60 hit the x squared, and you get 67. So the distance is 67.082 nautical miles. So this side of the triangle is 67.082, and this would be nautical miles. All right. So now what we're going to do is we have to figure out what theta is, because if I can figure out theta right here, then my bearing is going to be 90, 180, and then remember to here was 200 plus theta. So I would just do 200 plus theta, and that would give me my bearing. So I'm going to use tangent, which is opposite over adjacent. So you would say the tangent of theta is equal to 30 over 60. So the tangent of theta is equal to 1/2. And so how you find tangent is you would say theta is equal to the inverse tan of 1/2. So on your calculator in degrees, you would hit second tan for inverse tan and then put in 1 divided by 2. And this is going to give you 26 degrees. So theta is equal to 26.565 degrees. Now, you could say, so if you wanted to, you could say that the bearing, you could do 20 plus the 26, and you could say the bearing goes from south, north, south, east. No, that's west. West, east. Okay, so you could say, okay, well, the bearing is going to go, so there's different ways to write it. You could say the bearing's going to start south, and it's going to travel this 20 plus theta. So if you just added 20 to it, you get 46.565 traveling west. Or if you want to do the bearing just starting from the north and going all the way around to here, then you would take 200 degrees and add theta. So if you take the 26 and add 200 to it, it has a bearing. And when you say bearing, your bearings always start north and then go all the way around in this direction, a counter or a clockwise direction. So the bearing is 226.565 degree bearing. All right, so 2 different ways to write the bearing. So simple harmonic motion describes the motion of something that oscillates. You could think of a slinky going up and down as an oscillation, or maybe think of a clock that has a pendulum that swings. You could also think of the ocean waves that keep crashing over and over as a simple harmonic motion. So you get this oscillation or vibration, rotation. It is modeled with this simple equation here. So frequency is going to be B over 2 pi. That's how often you get the rotation. The other thing, though, to remember is your period. So your period is going to equal 2 pi over B. And you can see that here's B in these formulas, okay? So let's look at example 4. It says a mass on a spring oscillates back and forth and completes one cycle in 3 seconds. Its maximum displacement is 8 centimeters. So displacement is the same thing as amplitude. It's going to be your distance from the center up or the center down, right? And so that's your displacement. The period is going to be 2 pi over B, which is going to happen every 3 seconds. So that's going to be 2 pi over B equals 3. And then let's figure out what B is. So you'd multiply both sides by B. So now you have 2 pi equals 3B, and then divide by 3. And so B is equal to 2 pi over 3. So now let's just take this formula, and you can use the sine or the cosine. It doesn't matter. I'll just use the sine. So the distance is the equation that models this motion is going to be distance equals A amplitude. Uh-oh, what happened? So 8, and then you have sine, and then you have B, and B happened to be 2 pi over 3 times T. And this equation is going to change based on how much time you're looking at. And that's it for example 4. Pretty simple and straightforward. So please try the you try on your own. And then if you ask me in class, we can go over it. Thanks, everyone. Also, don't forget to do the reflection.